Alright, this video is intended for those who are still having trouble with Concept 35. This sheet here is the one you got on the first day that went with the first lesson. I'm going to do only some of the problems on this sheet, not all of them. And as a reminder, you have to show me either this sheet fully completed or the Unit 7 Homework 1 titled sheet fully completed, one or the other only. This first box is a formulas review. Hopefully you were able to fill in all of these except maybe the last one, pulling straight from your notes that we took on day 1. So the sum of interior angles of a polygon are S is equal to n minus 2 times 180. The interior angles of a regular polygon are S divided by n, S being the sum of interior angles of a polygon and n being the number of sides. The sum of exterior angles of a polygon, we showed that regardless of the number of sides of the polygon, they always add up to 360 degrees. The exterior angle of a regular polygon is also something you can pull from your notes. We showed that if you divide 360 degrees, the sum of all exterior angles, by the number of sides that the polygon has, you can find the measure of one exterior angle. For this last one, there's two possible answers you can have. You can solve for n based on the first one, and that will give you the number of sides of a polygon, or you can use the shorter one, which is based off this one. Okay, and some of you already used it in some of the problems that you find in this worksheet. The number of sides of a regular polygon, you can divide the sum of the exterior angles, because it's true for all of them, 360 degrees, and you can divide that by the measure of one exterior angle. So ext for exterior, okay, and then the little angle symbol. So 360 divided by the measure of one exterior angle will give you the number of sides of a regular polygon. Regular meaning, of course, that all the angles are the same. So you can use this idea. For the first practice question we're going to do, let's look at number 3. It says, what is the measure of each interior angle of a regular octagon? The key word here is each. So we're not finding the sum of all the angles within this one. We're finding the measure of only one angle. So you can use your table from day 1 notes, and you'll know what the sum of the interior angles of an octagon is, or you can use the first formula to find it. We have 8 sides, so I plug in, and again I'm plugging into this formula here. Okay, 8 sides, so 8 minus 2 times 180. That's going to give me 6 times 180, and that gives me 1080 degrees. And again, it's each interior angle. This is the sum of all the interior angles. We know we have 8 sides, so 8 angles inside. You have 1080 divided by 8, because that's how many angles we have, and that gives me 135 degrees. So this is the measure of one interior angle of a regular octagon. For the next one, let's do number 5. It says 5 angles of a hexagon measure 119, 129, 104, 139, and 95. What is the measure of the 6th angle? So a hexagon, of course, is 6 sides, so we have 6 angles. Okay, we know that the sum of a hexagon, of the interior angles of a hexagon, would be 6 minus 2 times 180, and that gives me 4 times 180, and then that's equal to 720 degrees. What I have to do is find the measure of the 6th angle. I can add the 5 given angles, So 119 plus 129 plus 104 plus 139 plus 95. Okay, when I add those those 5 angles, okay, so 5 angles added together, do that in your calculator, you get 586 degrees. Since that's the sum of the 5 angles, you can subtract from the total that they add up to, which is 720. Okay, so 720 minus 586, and that gives you the measure of the last unknown angle, and you get 134. For the next example, we could look at number 7. Let's look at number 6 actually. That says the sum of the interior angles of a polygon is 1620. How many sides does the polygon have? So we know our formula to finding the sum of the interior angles of a polygon. S is equal to n minus 2 times 180. I know that I'm working with with a sum of interior angles of 1620. So this is S. They gave me S. I need to find N. So I have 1620 is equal to N minus 2 times 180. Okay, now it's about solving for N. I have a product on the right side, N minus 2 times 180. So I can divide both sides by 180. Okay, and they cancel out here. So I have 1620 divided by 180. This is going to give me 9. So I have 9 is equal to N minus 2. Then I add 2 to both sides. Okay, they cancel out there, and I get that N is equal to 11. So this polygon has 11 sides. For our next example, let's look at number 8. It says, what is the sum of the measures of the exterior angles of a nonagon? A nonagon, if you recall, has 9 sides, and this question is sort of like a trick question. Okay, it covers an idea that we stressed already in class. The sum of the measures of the exterior angles of any polygon is always going to be 360 degrees. Okay, and that's it. You're done. You don't need to solve for anything if you know the general idea here. For our next question, we're going to look at what is the measure of each exterior angle of a 20gon. Let's look at number 9. So it says, what is the measure of each exterior angle of a regular 20gon? So you have 20 sides, and I'm using, again, a given formula right here. Okay, so 360 degrees divided by n, okay, n being the number of sides, that would give me the exterior angle of a regular polygon. Okay, the question tells me we have a regular 20gon. Okay, so it's just about plugging in to this formula. They all add up to 360, divide by 20 because we're talking about a 20gon, and that will give you the answer for this one. Okay, I'm not going to write it in because it's pretty straightforward. If we look at, let's look at number 8. It says, if the exterior angle of a regular polygon measures 9 degrees, how many sides does the polygon have? So it's working with that same formula, but you're dealing with something that's already given. So it's 360 divided by n. That gives you the measure of the exterior angle. And again, this is pulling from the given formula here. Okay. Now they tell us what the exterior angle measure is. They tell us it's 9 degrees. So, and of course it's asking for how many sides does it have. So you're solving for n in this case. That's not given. So how do I solve for n? I multiply n to both sides. they cancel out here, so I get 9n is equal to 360 degrees. Then you divide by 9 both sides, and you get that n is equal to 40. Let's look at number 12. This is the last one I'm going to do. It says find the value of x. So I have a quadrilateral, a polygon of 4 sides, and I know that the measure of a quadrilateral, all the interior angles need to add up to 360. I have 4 given angles, so I can add these 3 here and then subtract from 360, and that gives me the last one. So I have 110 plus 79 plus 55 plus x, okay, the unknown, those 4 angles add up to 360 degrees. When you add these 3 guys up, you get 244 plus x is equal to 360. Subtract 244 from both sides, and you get that x is equal to 116 degrees. Okay. For the following questions from here, numbers 13 all the way to 17, okay, you're taking the same idea here. Okay, you count how many sides the polygon has, use your table to see how much they should equal to, combine like terms, and then solve for x. The only thing that I'm asking you to please look out for is that some of these are asking you, especially actually just number 15, they're asking you to plug x back in, okay, so that you can find the measure of the angle. So it's not just solve for x, okay, it's asking you to find the actual value of an angle. Okay, so please be wary of that, and good luck.